Everyone will tell you the same thing. Put too much in the prompt, and the model stops paying attention to it. Your system prompt gets long, your rules stop working. That is just how it is. I wrote a 200,000 token rulebook, put 8 rules inside it that a script can check, and measured whether the agent still followed them. It did, 98.4% of the time. That is not the video I planned to make, so most of what follows is me trying to break my own result, including the part where I nearly fooled myself. Here's the belief I set out to test. It shows up in conference talks and threads and the documentation of tools you use. Keep your system prompt short. Rules get ignored once the context is long. Put the important instruction at the end, because the middle is where things go to die. Some of that comes from real published work on retrieval. But the version that gets repeated is much stronger than the version that was measured, and it has quietly become something everybody knows without anybody checking. So I made the question narrow enough to answer. 8 rules written once. The same 10 customer messages, every time. The same model, temperature 0. The only thing I vary is how much unrelated policy sits around those 8 rules inside the prompt and where in the document they sit. If length is what breaks rule following, this is the setup that shows it. Every rule here is graded by a regular expression, not by a person, and not by another model. That constraint threw out a lot of interesting rules. Anything about tone or helpfulness or being on brand, but it buys the one thing this kind of video needs, which is that you can rerun it and get my number instead of my opinion. And I deliberately mixed 2 families. Some rules say do this, others say never do that. They are equally easy to write into a document. I wanted to know whether they are equally easy to keep. One detail that decides whether the whole thing is honest. The VAT rule is only scored when the customer asked about a price. The competitor rule is only scored when the customer named a competitor. If I graded every rule on every reply, I would be counting a reply as broken for not mentioning VAT in an answer that had no prices in it. That is not a failure. That is me manufacturing one. 3 rules apply to every reply. 5 are switched on by what the customer asked. Before varying anything, the control. A handbook containing only the 8 rules and nothing else. 203 tokens. 10 messages, 42 checks in scope. 42 out of 42. 100%. This is the number that makes the rest of the experiment readable. Whatever happens when I add filler, I know it is not because the task was too hard or my regular expressions were wrong. Around those 8 rules I put filler policy. Badges, parking, expense claims, meeting rooms, written in exactly the same register as the real rules, and never touching anything the 10 customers ask about. And every filler rule is unique. Different department, different deadline, a different reference code. That mattered more than it sounds. 5,000 copies of the same sentence is not a long document, it is a compression test, and someone in the comments would have said so correctly. 5 handbook sizes. The control at 200 tokens, then 7,000, 36,000, 110,000, and 202,000. Every one of those numbers is measured with the provider's own tokenizer, not estimated from character counts. When I asked for 5,000 tokens of filler, I got 4,600, and the number that reaches the chart is always the measured one. 10 messages, 3 positions for the rule block, 5 handbook sizes, 130 replies, 546 individual rule checks. Temperature 0 throughout. It cost about $4. It ran in a notebook you can open, and every reply is saved verbatim in the repository, including the ones where the model got it wrong. This is that run, not a reconstruction of it. Every line printing there is a reply that came back from the model and got graded by the regular expressions from a minute ago. The lines marked break are the ones where a rule was not followed. There are not many of them, which, at this point in the afternoon, was starting to be a problem for my hypothesis. Here is what came out. 100% at the control, 98.4, 96.8, 92.9, and then, at 200,000 tokens, back up to 98.4. Look at that last point. The largest handbook scored better than the one-half its size. Whatever this line is doing, it is not decaying. And the confidence intervals overlap almost everywhere, which is the statistical way of saying I cannot tell most of these apart. If you came here expecting a cliff, there is no cliff. An average across 3 positions can hide a hole in one of them, so here is the same data with nothing collapsed. 1 cell per handbook size and per position of the rule block inside it. Most of it sits between 93 and 100%, with no pattern you could draw a line through. Except for this one, 88% at 110,000 tokens, with the rule sitting exactly in the middle of the document. And when I opened those replies, it got better. The rule says end with ticket, TK, 4 digits. In that one condition, the model wrote ticket, 7890. It dropped the prefix. 5 times out of 10, at temperature 0, the same wrong output. That rule was at 100% in 11 of the 12 conditions and fell to 50 in this one. That is a headline. Lost in the middle. With a reproducible signature. I had my video. Before publishing that, one more run. Same handbook size, same position, same 10 messages. I changed only the words of the surrounding filler by changing the random seed. If the whole is about length and position, it stays. 30 out of 30. It vanished. The most interesting thing in my data was the particular filler text that one seed happened to produce, and nothing to do with the length of the document at all. If I had stopped one step earlier, this video would have a different title, a better thumbnail, and it would be wrong. 2 rules do break, consistently. Never name a competitor, and escalate anything about deleting data. But look at where they break. The escalation rule drops at 7,000 tokens, the smallest handbook with any filler at all, and never recovers. The competitor rule holds until 36,000 and then drops. Neither of them keeps sliding after that. That is not degradation by length. That is a cost you pay the moment the rule stops being the only thing in the document, and then it stops getting worse. Which means shortening your prompt from 200,000 to 7,000 would have bought you nothing here. Twice during this, the thing that had failed was my measurement and not the model. The first time my rule said include the word escalate, and I counted this must be escalated as a break because my checker wanted capital letters that the rule never asked for. I fixed the rule, not the checker. A rule a grader can misread is a badly written rule, and that is true in your production prompt too. The second time I was convinced a set of replies had been truncated by my token limit, I checked. The longest reply was 443 characters against a limit far above it. I was wrong, and the failures were real. 4 limits, and they are real ones. 1 model, 1 handbook. Thinking was switched off. A model allowed to reason before answering may well recover rules that this one dropped, and that is a different experiment I have not run. The 8 rules sit in one contiguous block, which is not how a real handbook is written. The filler is synthetic, and a genuine policy document has cross-references and internal contradictions that mine does not. And the design cannot tell the difference between a rule that was never attended to and a rule that was attended to and then lost while the reply was being written. Those are different problems with different fixes. So here is what I will actually claim. Across 5 sizes and 3 positions, up to 200,000 tokens, the length of the document on its own was not what broke my rules. What separated the rules that held from the rules that slipped was not where they sat. It was whether they were a checkable format or an open-ended prohibition. I cannot tell you it will hold for your rules. I can tell you the notebook is in the description, it runs in about $4, and if you get a different number, I would rather see it than not.